Large language models are optimized for zero friction. Their architecture predicts the most probable sequence of words to satisfy a user's query instantly, delivering a polished output with no effort required from the person at the keyboard. Biology operates on a different principle. For the human brain to encode new information into long-term memory, it requires cognitive friction. The act of struggling with a concept is what signals the brain to retain it. When you use an AI to provide a clear explanation for a complex topic, you remove that struggle. Reading a synthesized summary bypasses the biological encoding process, leaving a faint imprint on your neural pathways. This creates the illusion of competence. The illusion of competence is a cognitive bias where a person mistakes their ability to fluently consume an explanation for their actual mastery of the material. You are recognizing the words rather than understanding the system. Treating an LLM as an answer engine disrupts the biological mechanism of learning. By making the acquisition of information effortless, the technology ensures it remains temporary. Effective learning requires prompts that forbid the AI from providing direct answers. We can convert the LLM from an oracle into a demanding tutor. By establishing a pedagogical constraint engine, we program the AI to refuse easy explanations and instead require the user to perform the mental labor. This prompt architecture reverses the standard human-computer dynamic. By placing the AI in the role of the questioner, the user becomes the primary source of information. These 10 specific prompt architectures are designed to execute peer-reviewed cognitive science principles. They reprogram the AI to enforce mandatory mental effort. Prompt engineering for deep learning centers on the architecture of cognitive constraints. The first tier is generative retrieval. The Ebbinghaus curve shows memory decays without active recall. Passive reading fails. Prompts like Active Recall Generator change the AI to an examiner, requiring you to produce analogies and examples. This progressive recall escalates from basic facts to complex application. We can increase this effort with the Mixed Practice Architect prompt, which introduces the cognitive principle of interleaving. Most students rely on blocked practice, studying one single concept repeatedly. Interleaved practice disrupts this by mixing related concepts together during a single study session. Interleaving works by forcing you to evaluate which framework applies to a given problem, rather than executing a single memorized loop. Tier 1 architectures build the foundation of learning on active generation. Once basic retrieval is secure, the AI must enforce relational framing. Isolated facts are fragile. They require a map of the structural relationships between them. The Mental Model Forge prompt requires the AI to map concepts in a sequential hierarchy. It starts at core principles, derives the operating rules, and moves to specific examples. This top-down mapping exposes the architecture of a subject, preventing the memorization of floating data points. To lock these structures in place, the Visual Thinking Translator and Analogy Bridge prompts execute dual coding theory. Dual coding theory is a psychological model demonstrating that memory retention increases when information is processed through two distinct modalities. The prompt forces the AI to provide a plain text explanation alongside a visual or structural representation, creating redundant memory pathways. The Analogy Bridge prompt applies this by building structural connections between the target concept and a domain you already understand, mapping new mechanics onto familiar systems. The Simplified Strategist prompt then applies a compression test, asking you to translate these maps into elementary language to verify the model is secure. Tier 2 prompts convert retrieved data into anchored mental networks. The final tier of the framework is metacognitive regulation. This is the act of critically observing your own thought processes while you are executing them. To enforce this self-observation, we use the Socratic Drill Master and the Why-How Interrogator prompts. These prompts rely on strict negative constraints. The core command is, "Give me no answers." This adversarial elaboration targets the illusion of explanatory depth. The illusion of explanatory depth is a cognitive bias where we overestimate our understanding of a system until forced to articulate how it works. By asking why and how, the AI forces you to expose the gaps in your reasoning. We pair this with the Meta-Learning Coach prompt, which acts as a supervisory node to interrupt the study session. This prompt forces you to pause and evaluate your current learning strategy. It requires you to state what is confusing you and to adjust your approach in real time. Tier 3 prevents cognitive autopilot, ensuring the user remains aware of their own mental friction. Together, these 10 prompt architectures construct a 3-layer schematic: generative testing at the base, structural mapping in the center, and metacognition regulation at the top. These prompts provide a framework for self-directed learners to convert a passive chat interface into a structured pedagogical tool. The utility of an LLM in this context is its engineerable capacity to ask the right questions. This framework translates academic cognitive science into executable software constraints that can be applied to any subject. In an age of infinite information access, true deep learning requires the deliberate architecture of cognitive friction.